Hi, my name is Ted Wendt. I'm a professor of math and computer science here at Carroll College. My background, I actually graduated from Carroll College a little while ago, and then went on to graduate school and studied applied mathematics, partial differential equations, all sorts of cool physics-related things. My interest here is primarily in teaching. Right now I teach the introductory programming course, the data structures course, teaching a segment in the computer science seminar about parallel processing, and then I teach some math courses, occasionally the optimization, differential equations, and our Math in the Mountains course, which we'll probably talk about in a little bit.
So I'm Eric Sullivan. I've been here, 5 years, I think? Ted and I actually started at the same time. I teach primarily math, but I also teach some data science courses, so we'll be talking about the data science program here soon. Currently teaching a course in machine learning, which is a new course at Carroll. It's going to be part of our data science program going forward. But I also teach differential equations and calculus and linear algebra and things of that nature.
I'm Jody Fastine. This is my third year here, and I teach mostly math courses and math education. I studied math, and I study how humans learn math. So I have both sides of that part, and one of the things I like to do is build curriculum. That's something several of us are working on, is building textbooks and building resources that are open source, things that we can share with students free of charge. That's one of the special things we do at Carroll.
That's true.
I'm Terry Mullen. I've been teaching here at Carroll for almost 35 years. Teach math and engineering, lots of engineering classes and math classes, particularly in the math, statistics and calculus, engineering, statics, dynamics, solids, AutoCAD, fluids, some transportation. So.
Great. Okay, so we do have a question in. What are the different engineering programs available at Carroll?
Well, Carroll has two four-year engineering majors, civil engineering and engineering science. Civil engineering has two tracks, broad field civil engineering and the environmental emphasis. Engineering science has the engineering mechanics track, environment and public health track, and engineering science, what we call the flexible option, where if students want to concentrate in, for example, biomedical engineering or something like that, then they can tailor their electives to suit those interests. We also have dual degree programs, agreements with several engineering universities, where a student takes math and engineering courses at Carroll for 3 years and then transfers to the university and finishes up their engineering degree in 2 more years. After the 5 years are up, they have a bachelor's degree in math from Carroll and a bachelor's degree in engineering from the school that they transfer to.
Great. So then our next question is, what makes Carroll's programs, computer science, mathematics, unique to Carroll?
Gosh, I think that's a great question. We do a lot of things collaboratively. One of the things that's a little bit unique about us that you might notice just from the group of people here, we're all one department, the math, computer science, the engineering. We all work really, really closely in trying to coordinate our curriculum together. So when engineering students come in, their first, I think 4 or 5 sequence of courses that they take, in mathematics they take with some physics students, they take with the math students, they take with the computer science students, which means our applications in those courses are pretty broad. Our math students are learning a lot of physics and engineering along the way. They're coding from day one. Our computer science students are learning mathematics and engineering concepts that they can apply to a different number of their own problems. So I think that sort of intentional collaboration in our curriculum is really, really one of our strong points, one of our more unique points.
I think on the math side, I think our focus on doing applied mathematics and writing computer programs to actually help us do the mathematics from really early on is one of the things that I've not seen at any other universities that I think we do really well. Of course, I'm biased because I'm here, but we're having students solving large-scale applied problems from their very first semester that they're here, writing computer code to do it, and then they're taking those problems and doing deeper and harder problems in the next semester and in their engineering courses and in their physics courses.
And then they make presentations to their
that's
their peers.
Yeah, that's huge. Yeah, go ahead.
So we have a project-based idea where each term you're learning how to do a big idea and wrap it up as a project, whether it's a presentation or a poster or a paper that you're submitting. As freshmen, there's a lot of scaffolding around that, and as you get farther along, you're able to do more and more independently. This types of projects that you could then walk into a job interview and say, this is what I made, and the person who is interviewing is going to be really impressed.
In fact, that literally happened about 2 weeks ago with
Yeah.
one of our math students emailed us thanking us, saying, hey, if it wasn't for the projects that I had done in your classes, the interview would not nearly have gone as well, and I showed off all of these projects and I was hired by the end of the interview. So we do that well, and our students really take advantage of it.
And when it comes to engineering, it's unique that there's engineering at a four-year college in the first place. But most engineering majors are at large universities, research universities. A lot of the undergraduate courses are not taught by the professors. Here, they all are taught by the professors. The courses are smaller. Kids get a lot more hands-on opportunities in the math and science and engineering courses, computer labs and things, because the numbers are reasonable and manageable.
And I think to dovetail, I think on some of the stuff that everybody said, with respect to mathematics specifically, one of the most common questions we get asked from students coming in trying to study mathematics is, well, what am I going to do with this? I like math, I'm good at it, but I don't want to be a teacher. And I think we've put a really, really conscious effort into trying to design our curriculum so that there's an impact point, so that students, as they're learning material, will say, and I can see where this will be used, and I can see how this will be used in the real world. One of the courses that we've just recently introduced is a course called Math in the Mountains, where the whole point of the course is for students to engage with local nonprofits and businesses to solve their different types of problems. So for instance, a few years back, we had a group of students work with the Helena Food Share. And one of the Helena Food Share's challenges is trying to figure out when they need to do directed food drives, when they need to use some of their funds to purchase different types of food items, or when they're set when they don't need to stock anymore. So we had the students put together mathematical models saying, well, based on the rates of usage, based on the arrival rates and when people come in and ask for stuff and the different types of demands, how do we go about putting in an early warning system to say, hey, your threshold for canned goods is pretty close to emergency level. You should do a directed food drive. You should actually use some of your funds to purchase this. And none of the students going in had thought of, I can use math to solve this type of a problem and to help one of my local community organizations. The course has been running for 3 years now. We've worked with, I think, 7 or 8 different local nonprofits or businesses. And that type of a model is one that doesn't exist in most institutions. I think I'm aware of 2 or 3 other institutions where that exists, and it's primarily reserved for senior students as a capstone or for early entry graduate students. Our course is accessible to students right after their freshman year. So I've had one student who's taken the course 4 consecutive years.
They didn't have to.
They didn't have to.
No.
They chose to.
She keeps coming back over and over and over again.
So because we're a small department and a small college, and because we work so closely together, we're able to collaborate and say, this is something our students need. Let's make it happen. And there are a number of other examples of where that occurs in our curriculum.
Awesome, guys. So what types of jobs and internships are available for students kind of outside Carroll and Helena, and then even within Helena?
Well, pretty much all of our engineering students get some kind of summer job, probably from their sophomore year on. And we have a career center here that they get notifications from people that want have summer openings. We have a system in our department. Gary Fisher is the one that handles it usually. He gets emails from employers all around the state, Helena, but also around the state. And we have group emails where once those announcements come in, he shoots them out. So we have a pretty good way of communicating those openings to the kids. Of course, they come in and ask us. I work summers as an engineer at a local engineering firm, and so does Gary, and so does Willis Waite, another one of our professors. And so we know a lot of the folks around town, and just some of that word of mouth helps the kids get work too. But they all, by the time they're juniors and seniors, have been working summers and even during the school year for an engineering firm somewhere.
And then with regards to computer science, being located in the state capital is really, really convenient for us. I think it's the same for engineering. There's a lot of different opportunities for students to intern with different state and local government agencies. There's a good industry base for computer science in town, we typically have more internships than we can fill. So there's a good demand in the computer science sector for students looking for work. And I think if not following the completion of the freshman year, certainly after the sophomore year, students are out there in the workforce getting a lot of experience.
Well, in math, we've had students doing research experiences for undergraduates, so REUs, at various institutions around the country. We had a student last year go to New York for an REU where they were studying the mathematics of the heart, which was really neat. They didn't know any biology going into it. They learned lots of biology, lots of math, and did some pretty cool projects. They've actually presented that at national conferences now, too. What was our other REU student doing?
UWL at...
Oh, that's right. Mathematical biology studying blight of chestnut trees. So, again, they didn't know any biology going in, but they knew the math and computer science really well. And this was a student who was actually double majoring and really thoroughly enjoyed the experience, was able to use that on applications, and is now heading off to graduate programs to do similar sorts of things. So it's another experience that our students have over the summer is getting into these REUs.
And I think one of the things for the math program, as part of the math program, a student majoring in math is required to have either a concentration in a particular area or a second minor or major. So we try to pair their mathematical interests with something that they can apply it to. So somebody who takes, say, the math chemistry concentration will be well suited to take chemistry research positions or math research positions or some sort of combination. And I believe we have maybe a dozen or so different concentrations that students can choose from for their focus in addition to the list of majors and minors.
Wonderful. So could you talk about what other student opportunities there are available, maybe like, for example, Engineers Without Borders or any other groups like that, maybe clubs or opportunities for students in any of the programs?
Well, in engineering, we have two primary clubs. Engineers Without Borders is the biggest one, and it's been around a long time. Students work on projects in foreign countries. We have a project in Mexico, another one in Guatemala, one in Africa, and San Lucia. And these are usually, a lot of times, water cleanliness or water supply projects. The nice thing about being in Engineers Without Borders at a place like Carroll, I mean, the large universities have Engineers Without Borders also, but here the kids, even freshmen, get to jump right in, work on a project, even travel right away. And the other club, American Society of Civil Engineers Student Chapter, they do service projects, and there's always a major competition in the spring in the Northwest at one of the universities, concrete canoe competition. They race concrete canoes and build steel bridges and various things like that. So there's plenty of those kind of things, those kind of the club aspect that is available to engineering students. And you don't have to be an engineering student to be in the EWB either. We have plenty of biology majors, nursing majors, and others that also are in that program and go on the trips. They've even been the president of the organization as a non-engineering major. So,
Can we talk about our competitions?
Yeah,
Is that
go for it.
So we have a number of competitions in the math and computer science area. We've got the Association for Computing Machinery competition, ACM, and that one is when we send students to, but we also have a few competitions that happen on campus here. One of them is the 24-hour modeling competition, and the other one is the 100-hour?
100 hours.
100 hours, yep.
And students work on modeling real-world scenarios. Last year's competition included modeling some fire evacuation situations out of Glacier National Park. Previous years we've looked at the Syrian refugee crisis and the mathematics that's going on and redistribution of populations like that. What other really awesome ones? There's one about bacon and seaweed.
The seaweed bacon one?
There was
Yeah.
one about the potential implication of large-scale harvesting of a new type of seaweed that tastes like bacon. Students were asked to determine what type of an impact that might have on the pork industry, on people's health, and on the global environmental picture as a whole.
And students work in
That one was
teams
fun,
of 3,
Yeah.
and it's just a fun event where you really get to know the math problem, and you have lots of fun working with someone else. You have the option of all sorts of computer interventions as well, so it's not just you and a calculator. It's a little
Yeah, I
more
think
intricate than that.
I think the neat thing about those the math modeling competitions, the 24-hour one we do in the fall and the 100-hour one that's international that happens in the spring, is that at face value, none of the questions are really math questions. They don't seem like something that you would say, I'm going to do this calculus problem, or I'm going to solve for X. None of them seem that way, but all of our students are asked to leverage what they know about mathematics to actually solve these problems, and they do really well. In the 100-hour competition, it's an international competition where our students are fairly consistently placing in the top 10 to 15% worldwide. So we're doing really well in this, and
we've had 3 international winners.
Yeah.
So top 2 or 3 teams in the world since 2003.
I just got done grading. I've been grading those papers for years. I just finished grading 300 of those things.
Oh, you're a brave soul.
Problem B, which is about the evolution of foreign languages in the next, say, 40 or 50 years, and how many language speakers are going to be of, how many, and where should I locate my offices, in what countries and things like that.
And the neat part about these problems, one of the frustrations a lot of students have about math is so much of mathematics is going through particular motions, and you get to the end, and I can't tell you how many times I've heard students say, well, I got the right answer, why does it matter how I did it? And when you look at these real world problems where the mathematics is actually being applied, all that matters is that you've got something that's defensible and that explains the situation that's going on. And it really is you and any resources you can find against the world, and it's not so tied up in the minutia, and it's not so tied up in the, well, you didn't do it a particular way, so you lose 3 points here. It's, did you answer the question, and does your answer hold any water? And I think students really embrace that, because that's where our students go when they graduate. They go out and they solve these problems.
Well, an interesting thing to add to that, too, is that these are not just isolated incidents in the competitions. While the competitions let our students really highlight that part of their knowledge, we've embedded that idea into all of our mathematics classes, where the classes have a lab component to them, where they're doing something open-ended and kind of, they have a little bit of free will in how they solve these problems. Look something up on the internet if you need to, write some code if you need to, solve these problems in a creative way. And so every single week we're giving large-scale open-ended problems for students to solve that are solvable within a week, don't worry. And then in the end, like Jody said before, we've got projects that'll let them highlight even bigger problems.
Right. One of my favorite ones was the Orion space capsule that lands in the ocean. How do you make sure it doesn't tip upside down? What can you do to check how it's behaving? That's fascinating. Students did all kinds of cool things with that.
Fantastic multivariable question.
Yeah, and one that I'm going to ask soon is, how do you evade a pursuing velociraptor? Because it's an important question. I mean, but it doesn't seem like a mathematical question at the outset, but it is.
Awesome. So you guys have all kind of been here for different amount of time, but what's been each of your favorite parts teaching at Carroll? What's been your favorite things about Carroll?
Well, go ahead.
Oh, no, you go first.
Well, that's the best thing about my job. It's just so rewarding. Being a college teacher is a great job. And I just ran into a lady at Costco the other day, and she said, Mr. Mullen, I had you in 1988 for calculus. And she said a bunch of really nice things, and I was floored, and she told me her name, and I remembered her, but I didn't recognize her at the time. So just that kind of stuff happens all the time. And we get so attached to our kids. I teach from freshman to senior, probably all the students in a given class, maybe 6 or 7 times. So you really get attached to them by the time they graduate. So it's just rewarding. It's like a family. Yeah. And I'm the grandpa nowadays.
Can we call you that?
Yeah.
So at my last school I worked at, there were 50,000 students, and I would have a student in a class and never see them again the whole time I was there. I love that at Carroll I see the same students over and over again. I'll have students come to my office hours who I had a year ago. I don't have anymore, but they'll come and ask me questions, so I get to see what they're up to. And I can have the same student 3 or 4 times and really get to know them and their strengths and how to support them. So I love that about Carroll. Yeah.
Well, I would just say what they said. So I'm gonna add something of a little different flavor. I like the people that we work with here, and that if I have trouble trying to come up with a way to introduce a topic, or if I've got a project idea that I'm not sure is going to work, I can always just knock on Dr. Fasteen's door and say, okay, here's my idea. Is this going to work? And she will just tell me flat out, no, that's a horrible idea. Or, wow, tell me how that turns out. Here you go.
Or change this.
Yeah, right.
And
So the fact that we work so closely together, I think, really helps the students as well, because there's a lot of continuity from class to class, where it's not just that they're going to see one thing in one class and never see it again. It's the themes that we have throughout the courses come up over and over again, and it's because we can work really well together. And we do.
Right. And I think I would say exactly the same thing, but in the interest of doing something different. And this may sound weird. It's extremely invigorated to be surrounded by such brilliance and such energy from the students and from the faculty. Watching the students work together, you see the excitement, you see the desire, you see them wanting to better themselves, and they lift each other up. And they help each other collectively reach heights that they may not have been able to do on their own. And I think the same can be said for the faculty. I've worked at a couple of different places, and I can say hands down, the quality of the faculty here is second to none. It is incredible what the faculty do. It is incredible what the students do, and it is absolutely amazing to be a part of that. In addition to what y'all said.
Yeah, and the camaraderie.
That's
You know,
right.
Yeah.
we get along really well. Ted's the new department chairman, which means he's the chairman of engineering, math, computer science, all
And
of it.
data science.
data
Data science, the new program.
Yeah, the new program.
Do you want to talk a little bit about that new program?
Sure. Yeah. So the data science program is being housed in this department, so it's really kind of a part of math and computer science now. It's just been approved, so it's going to be a new major coming online soon. We've been piloting courses for that for the last couple semesters. Currently, I'm teaching a course in machine learning, which is kind of the mathematical side of artificial intelligence. For the first time we've ever run that course, we had 13 people sign up. I figured we would have 4 or 5, but there was actually quite a lot of interest. And they're junior and senior math and computer science majors. I have one junior, biology, chemistry with a math minor or something like that, who was just interested in the topic. So I mean, we're doing really interesting problems on large data sets. The last project that they were working on was actually working on classifiers for breast cancer data, and the teams were able to come up with classifiers that were correct 98% of the time on real-world data that was gathered from the University of Wisconsin Medical School. So really neat problem. A couple days ago, we were looking at how well a company was doing based on its Facebook metrics, which was a great fun problem. So the data science program itself will include machine learning, will include some advanced statistics, but will also include computer science topics like databases and advanced computing for data science. Data science itself is a relatively new field. So in the last 5 years, it's climbed from being a field that didn't exist to being one of the top 5 or 6
fastest growing fields for jobs right now.
Yeah, it's growing faster than we could possibly keep up with. So, if you're interested in data science, reach out to us. This is a program we're really excited about, and it's one that's I think it's really going to blossom here.
According to LinkedIn, it's I think the number 1 or number 2 job for need. We need more than we have right now. So.
Well, it's also unique in Montana in that there's one other school in Montana that has a data science program, but ours undergraduate program. Ours really marries computer science and math together, along with some of the newer fields like machine learning and the advanced computing parts. That the other undergraduate programs around the country aren't marrying them as well. Maybe those programs are spawning out of the statistics program, so they have more of a math stat bent. We're trying to actually blend the unique mix that we have here together into that program.
Right, and speaking with people in the field of data science who are hiring, typically they'll say there's 3 things they're looking for. They're looking for somebody who's capable of doing the mathematics and the statistics. They're looking for somebody who's capable of writing a script to implement their stuff. And then they're looking for somebody with some sort of a content knowledge. So if the data science is applied to finance, then they want somebody who's got a financial background. If the data science is applied to biomedical stuff, then they want somebody who's got that.
Environmental sciences.
Environmental sciences.
Yeah.
So built into our program already with mathematics, we've got that where you're getting the additional discipline in either a concentration minor or major, which really, really prepares people to go forward and succeed in those new jobs.
Awesome, great. So we did have a student reach out to us and ask, what is the best computer for going into engineering or computer science or mathematics? Is there one you recommend?
I think really we don't have much preference right now on campus. Most of our campus resources are PCs, and we've got pretty good support for those. At the same time, I think right now most students come in, we have maybe a 50-50 split between
That's probably fair.
Macs and PCs. What we really need is that you have a computer, a laptop computer that's portable, that you're familiar with, and that has enough power to run a couple of programs. So if you're looking for a new computer and have questions about what you want to buy or have one in mind that you'd like us to spec out, feel free to contact us. We'll talk to you about it. But for the most part, any off-the-shelf PC or Mac will do the job.
You need to be able to install your own software. So something like a Chromebook, while being a really good piece of technology, doesn't actually work as well for us because you can't actually install extra software on top of it. Things like statistics software or things like that. I don't know. Anything else?
Cool.
All right.
Awesome. So more and more often we're finding students that are starting coding in high school and kind of are already pretty proficient with doing that kind of thing. So how early at Carroll can you start doing the coding and kind of getting in and all that?
Day one.
And I think that's across the board. In the computer science courses, of course, we'll start coding right away. But also in the math courses.
Well, the robotics is
the
there.
robotics
Yeah,
course.
the robotics course is...
So yeah, one of our introductory courses that we try and channel our STEM students into is an introductory robotics course. And we want that to be a place where we can build cohorts with first-year engineering students, first-year computer science students, first-year physics and math students. So that's one potential entryway into coding. The introductory computer science course is a first course in coding. The math courses, our calculus sequence from Calc 1, we're spending at least a day a week in the lab using software to solve these math problems that are bigger than we can do by hand. So as soon as you want to get coding, we'll get you coding, maybe sooner.
Well, yeah, we realize that that's kind of an integral part of doing applied mathematics outside of school. You know, I want you to know how to solve for X when the time comes around, but at the same time, oftentimes problems are way too hard to do by hand. So we're going to teach you how to code so that you can solve applied math problems of a real scale.
Did you really just say that coding was an integral part of calculus?
I did say that. The pun was intended, and I'm glad you picked up on that, Ted. That makes me happy.
Okay.
Terry, you know what you get.
So another question we have is, what types of systems do you work with within each of the majors? Maybe operating systems or...
So I can start with computer science. Computer science, we have courses for operating systems. We work primarily on a Windows platform, but we do have courses where we work with Linux and install different types of distributions there. For coding, starting in the fall, our introductory coding course is going to be in Python. But coming through the CS major, a student will pick up Python, will pick up Java, will pick up MATLAB through their mathematics courses, will pick up R through their statistics courses.
And data science courses.
And data science courses. We'll pick up C++, and then a handful of other things. Our web design course, you'll learn HTML, CSS, maybe some JavaScript. The database, you'll learn SQL, PL SQL. So by the time a student gets through the computer science program, they will have half a dozen to a dozen different types of programming or software languages under their belt.
And once you've done several languages, you get the ability to pick up new ones as you're moving. You kind of learn
Really
how
quickly.
to learn a language, and that's a great life skill because you might get to a job where there's a language you've never heard of, but now you're confident in learning a new one because you've done it several times.
Actually, one of our former students said exactly that. Said, the first week of my job, my boss came in and said, "Here's the programming language we learn, or we use. Learn it. I'll give you your first job in a week." And our students come out with enough skill set to be able to do that. In math, we're using primarily MATLAB and R to do most of our computation. But more and more we're leaning on other tools like Java and Python as well.
What you youngsters don't understand, you graduating seniors, is you're really good at computers. When I throw you on anything like WebWork or AutoCAD or Excel or whatever, they pick it up so fast.
Yeah.
They're not afraid of it
Yeah.
or fazed by it at all.
There's
So
a learning
You're
curve.
as prepared as more prepared maybe than you realize you are.
Yeah, there's a learning curve
There is.
to every piece
Yeah.
of software, but it's about being open-minded and saying, hey, I want to learn some more software, and I want to learn how to do kind of modern mathematics or engineering or computer science. So
You learn to handle the learning
Yeah.
curve.
And
yeah,
we
and the
don't-
learning
we
curve
don't-
happens pretty quickly.
We don't throw you out to do it on your own. We have a lab-based system where you're
That's
doing
true,
a lot
yeah.
of the coding, and there's a professor in the room with you, and there's other people around to help you, so you're not on your own.
And
doing
YouTube videos with my voice in the background to help you out.
Well, we are running right up about time, but I just wanted to give either any of you an opportunity if there's something you want to briefly touch on or tell students considering coming here before we wrap up.
I just have a funny story about Ted.
Oh,
I just
no.
thought of it. I called him last year. I was teaching statistics, and I said, Ted, there's this how to make a histogram in Excel video. I haven't looked at it yet. Is it any good? He goes, well, I made it, so I hope so. I didn't know it was a homemade video. That's what I did.
What he doesn't know is we've since deleted that
Yeah.
video. No, I'm kidding.
It's still out there.
That's beside the point. I just thought that was a kind of a humorous thing
I'd like
from
to
last
add something, and we haven't mentioned that we have math for secondary teachers. So if you are interested in becoming a K-12 teacher, particularly if you're interested in math, we support that. We have a great program. You're a math major first, and then you're also adding what you need in order to become a teacher. And we have some great experiences. If you would like to become a teacher, we can have you helping with lab classes and tutoring and getting a lot of those experiences as a teacher from your freshman or sophomore year and building up on that. And then in your senior year, we'll often have students co-teach a class with us right alongside a professor to really get your feet wet before you even go out to student teach. You would have a lot of these experiences. So we're definitely welcoming. If you'd like to become a teacher, we can support all of that as well.
Oh, and that really helps with recommendations. When we've had former students come through who have co-taught with us, we get a phone call from a principal a year later that says, hey, this person's applied for a job. Are they a good teacher? And I can say, well, yes, I taught with them for an entire semester. We wrote all of our lesson plans together. We wrote all of our exams together. I know how this person teaches. So our references really go a long way in that regard.
Right, and I think, just the closing note from me, there's a lot of things you can do when you go to college, and one of the strengths, I think, of our program is that we really, really foster that sense of exploration in our students. We want our students to learn cool stuff, and if they know something or found something that we don't know anything about, but it seems neat, we're passionate, we're willing to pick it up and study it. And you might have picked it up throughout this chat. We're excited about this stuff. We love what we do. It's fun to come to work in the mornings, and it's fun to work with students on these things. So, as you go through and make your choices, every place you go is going to have a class list and a catalog, and you can look through and pick out the ones you like. But a lot of times it's the stuff you do in addition to the classes, to supplement the classes, that really defines what your experience is. And I've said it before, in that regard, I think we're second to none. I think we can provide you with all sorts of different types of experiences that are genuinely unique. So.
Wonderful.
Great.
Thank you all so much for your time, and for those of you watching while it's live or later, if you have any other questions about math, computer science, or engineering at Carroll College, feel free to leave us a comment and we will be able to reach out to you directly to answer any questions. Thank you.